video, we're going to be talking about combined variation. Recall that if we said x varies directly with y, or if we say y varies directly with x, y varies directly with x, this implies this mathematical equation, y is equal to k times x. If we were to say y varies inversely with x, this would imply this mathematical expression. Now, what if we were to introduce a third variable, z, and said y varies directly with x and inversely with z? Well, this is what you would get. Y varies directly with x and inversely with z. This sentence implies y is equal to k times x in the numerator because it's direct with x, divided by z because it's inverse with z. Okay? So now that we've talked about how to use sentences that involve both direct and inverse variation, let's apply it to our ball here. We discovered in one of the videos that pressure and volume were inversely related, meaning P was inversely related to V. However, P and T, T for temperature, temperature of the gas inside the ball, are directly related. If you think about temperature as the rate of molecular motion, if we somehow were to decrease the volume of a container, then those molecules, if we didn't change the number of molecules, those molecules, if they were smashing around like this, and we decrease their container size, well, they'd be smashing around much faster. They have much less room, so they're going to jiggle around, bounce around, and hit each other much faster. And then thus, it'll increase the overall temperature of the system. So, we can create a physical situation and say that our pressure varies inversely with volume, but directly with temperature. This sentence allows us to express this mathematical algebraic statement. The v in the denominator and the t in the numerator. Okay? Now, let's solve a problem. Let's say, given the pressure is equal to 100 millimeters of mercury, and let's say the volume is equal to 10 milliliters cubed. And furthermore, let's say the temperature is equal to 50 degrees, okay? We'll use Celsius. Given at this point our system is like that, let's ask the question, what will the temperature be if our pressure and our volume go up? Let's say pressure, we multiply it times 10, it becomes 1,000 millimeters of mercury. And let's say our volume, we decrease that volume, let's say, to 5 milliliters cubed. We'll half the volume and multiply the pressure times 10. Tenfold increase in pressure, and just halving the volume. What does that do to the overall temperature? Well, again, we use this first piece of the problem to find K. Right here, we can solve for K by saying PV over T is equal to K. All I did was I multiplied both sides by V over T. Alright? So then I get, this is equal to 100 times 10 all over our temperature, which is 50. So we'll find out that K is equal to 100 times 10 divided by 5 times 10, because that's what 50 is. I can cancel out some 10s here. 100, that's really 2 times 50. Just doing a mental calculation, so that's really 2 times 5 times 10. Cancel out 5s here, so this reduces to 20. So K is equal to 20. Aha! Now, voila! We know what K is. We can now calculate what T is in the problem down there. What will T be if the pressure is 1,000 and the volume is 5? We set up our equation again. P is equal to KT divided, P is equal to KT divided by V. Okay? And we want to find what is the temperature. So we'll solve for T. That implies I get Vp all over K is equal to T, because I multiplied both sides by V over K to solve for T. Then I replace the value for V, which we say it's 5. Oh, I just noticed here in this part, no, that's correct. That's correct. Over here, we use the new volume 5 with the old pressure, with the new pressure 1,000 divided by what our K is 20. So whenever we find this, we'll find our new pressure. What is the new pressure in this situation? Well, 5 times 1,000, that's really 5 times 10 times 100. Okay, divide that by 2 times 10, which is really 20. I can cancel out some 10s here. We might be able to cancel out a 2 here, because 5 times 100 is really 5 times 2 times 50. Divided by 2, cancel out these 2's. So I got 5 times 50. 5 times 5 is 25. So I got 250 is equal to my P. So our new pressure is 250 millimeters of mercury, which is just one standard unit of pressure. What's most important is that you realize how to translate those sentences into algebraic statements.